Hello and welcome to the channel. In this video, we are designing a traffic light controller using Simulink in MATLAB. So this video will provide a practical workflow for Verilog based implementation of the traffic light controller and FPGA integration. So these are the key highlights of this project. First, we will design the traffic light controller using Stateflow in Simulink based on real world conditions and timing constraints. So we will make a Murray based FSM. We will add the states, transitions and the conditions in the Stateflow chart to model the system behavior. We will debug the errors using the symbol wizard and configure the state machine as a Murray model. We will connect the step and scope blocks to simulate the Simulink model and analyze the output waveforms. Finally, we will also enable the monitoring of state transitions using child activity outputs and logic analyzer. Then we will move to doing the HDL based implementation of this. So we will identify what are the HDL compatibility issues using the check HDL command due to the double data types that are used in the state model. We will then resolve these data type issues by adding the data type conversion blocks and using Boolean data. Then we will configure the HDL coder for Verilog generation and FPGA specific clock settings. The last step will be to successfully generate the synthesizable Verilog code using the makehdl command. So this video will cover the key concepts like Stateflow design in MATLAB, debugging the errors and HDL code generation. So this is the basic traffic light controller system that we are designing. So you can see we have a local road and we have the sensors to detect the traffic or any car on that local road. So we have written here car sensors, but they can be used to detect any kind of traffic. So a busy highway is intersected by a local road. This sensor will detect the vehicles on the local road. We have given it a name as C, capital C. If there is no traffic on the local road, the highway signal will remain green and the vehicles on highway can pass. But if there is the traffic detected on the local road, the highway signal will first turn yellow, then it will turn red, and when the highway signal is red, then only the local road signal can turn green. We have also defined the timing constraints. So the highway signal will be green for at least 15 seconds even if there is traffic on the local road. The local road signal can stay green for a maximum of 10 seconds only, and after those 10 seconds have passed, that the signal on the local road will become yellow and then red, and when the local road signal is red, then the signal on highway will turn green. The highway signal will become yellow for only 5 seconds and the local road signal will stay yellow for only 3 seconds. So these are the timing constants. Now we will go to the implementation part using MATLAB. So we are in the MATLAB window. We will click on the Simulink to open the Simulink. So after Simulink has opened, now we will type HDL lib. HDL lib command in MATLAB to show only the HDL compatible libraries, and to restore the default view we have to type HDL lib off. So now only the HDL compatible libraries will be shown in Simulink. So now we will go into the Stateflow and use the chart and add it to our model. So this chart will be added to our model. So we can see that this chart is added to our model. We can also give a name to our model by clicking on Ctrl S. So I am giving it a name TLC underscore Kush and going to save. So this will save our model. Now we will double click on this chart. So this chart window has opened inside this Simulink model. We will drag the state. So this is the state. We will drag the state. So this arrow shows that it is the reset state. We need total 4 states. So we will drag these 4 states. We can also use the Control C and Control V command. So the 4 states have been dragged and dropped. We can go to fit to view. So this will be the fit to view. We can also draw the transition between these states. So in this way, these are the state transitions. And for self transition, we can draw a self circle. So this is the self transition. Again, click on fit to view. So we have created 4 states here. Now we can just type anything in these states. So first I am giving a state name as S0. This is the reset state. So in this state, the highway green will be 1, the highway yellow will be 0, and the highway red signal will also be 0. The local green signal will be 0. The local yellow signal will also be equal to 0, and the local red signal will be equal to 1. So this is the state. These are the variables for this state. We can also make it bigger. So we have drawn the 4 states and labeled them. So in the state 0, the highway signal is green, the local signal is red. In the state 1, the highway signal becomes 0, the local signal is still red. In the state 2, the local signal becomes green and the highway signal becomes red. Then in the next transition, the local signal becomes yellow, the highway signal is red, and finally it comes back to the reset state where the highway signal is green and the local signal is red. So now we will draw the transitions, or we will label what are the conditions for the transition. So if there is no vehicle on the local road, then the highway signal will become green. So it will be denoted by this C equal to 0. So this is the condition. We will write it in the square bracket. So if C equal to 0, then the highway signal will remain green. Also for this transition, we will write if C equal to 1 and after 15 seconds. So because the highway signal has to remain green for at least 15 seconds, and the highway signal can become yellow only after 15 seconds. So we have typed C equal to 1, and after 15 seconds this transition will occur. So these are the transitions. If there is traffic on the local road, then the highway signal will remain green for at least 15 seconds and then it will turn yellow. The highway signal can be yellow for a maximum of 5 seconds. So after 5 seconds, the highway signal will transition from yellow to red, and when the highway signal becomes red, then the local signal will become green. The local signal can remain green for only 10 seconds, for a maximum of 10 seconds. So after the 10 seconds have passed, we will transition from S2 to S3 and the local signal will become yellow. The local signal can stay yellow for only 3 seconds. So after 3 seconds, we will come back to the reset state. So here we have written the condition after 3 seconds. So these are the state transitions. We have also written the state conditions. Now we will run this state diagram and see the outputs. Now we will run our state model. So we will click on run. So it is compiling. So it says there are some unresolved symbols. So this C is the input. So I will select it as the input and click on OK. Now this C is selected as the input. I will run it again. Run. So it is compiling. So it has completed the compilation, and now you can see that this chart is now created to my Simulink model. So let me zoom. So as you can see, this is the Simulink model, and in this chart is present. So to simulate it, we will use a scope. So I will add a scope block to my model. So I selected the scope, this scope appeared, and I will add this block to the model. So now I have connected my 6 outputs to the 6 inputs of the scope. Now there is the 7th output. So I also want to monitor the state. So for that I will go into the chart. I will go into this modeling. I will go into chart properties. So I want to now select the type of the state machine. So the output of our system is dependent on the states. So that is why I selected the state machine type as Moore. I also want to monitor the states. So for that I will create this create output for monitoring child activity. Click apply, click on OK. Now you can see that we have one new signal that is called as chart mode. So I will connect this also. So now the block diagram is complete. So this chart mode is for monitoring the states, and it is Moore. So it is showing that we have created a Moore type state machine. Now I want to give an input using a step block, but we are in HDL supported libraries. So in HDL libraries, there is no step block. So for simulation, I will type this HDL lib off, because we want to simulate first, but in HDL there is no step block. So for getting the step block, first we have to turn off this HDL library browser. So now we will select a block. We will go into the library browser and we will select the step block. So I will add this step block to my model. So I will give the step time as 15. Initial value is 0, final value is 1. And I will select the stop time as 60. So now we will save our model. Now we will run according to HDL setup. So we will give the name exact as our model. So our model name is TLC underscore kush. Click on enter. So it is giving some warnings and some errors. So these are some of the errors, and now it is showing like this. So we also want to select the sample time as 0.1. So again we will go to model settings. So this is auto. I want to select it as 0.1. So click on OK and apply. So now we will run it and see the outputs. So these are the outputs. Let me select the layout view. So let me also select the legend. So as you can see, okay, so we can see that our for 15 seconds our car sensor was 0. So for 15 seconds you can see the time is coming here. So for 15 seconds, and then again for 15 seconds the signal, the highway green light was 1 and the local road red light was also 1. After this time, the highway, after this 30 second, the highway yellow signal got 1. So the highway green signal got 0. Then the highway red signal got 1 when the highway yellow signal was 0. And similarly, so we can see the state also. So for 30 seconds, the system was in state S0, then it changed to S1, then S2, then finally S3. So as we can see that this state model is verified using the simulation. So we can close it. We can also see in the logic analyzer. So we can select log selected signals and open in logic analyzer. So we will run. So again, these are the various signals we can see: S0, S1, S2, and then again state was changed to S3 and finally to S0. So in this way, using MATLAB, we can verify our traffic light controller is working properly or not as per the state diagram. Remember, this is the simulation that we have done using the state model. So now we want to generate the Verilog code for our system. So now we removed the state monitoring because that was only for simulation. Now we will convert this model to a subsystem. So press Ctrl G. So it is converted to a subsystem. Let me give it a name. So this is the name of this subsystem that I have given. So this is my subsystem. And now you can see that the outputs, the type of the output is double. But in Verilog, this double type is not supported. It has to be a fixed value. We can also see this in the MATLAB command. So if I type check HDL, then the name of the model is TLC underscore Kush. And in that the subsystem name is TLC underscore Kush underscore SS. So if we run it, it will give some errors. So as you can see, it is giving error. The model contains double type signals. To generate synthesizable HDL code, we have to either select the floating point checkbox or change the double type signals to fixed point data type, because double type is not synthesizable. So it ran HDL checks on our model and generated this report. So to change the data type, we will now add a block for data type conversion. So we will add this block to our model. And the output should be Boolean type. Click on apply. I will add this block in between. Again, I will run it. So as you can see, now this is perfect. This is double. So it is coming as Boolean. But so it is also black. Black means there is no error. But these again still are red. So we have to change the data type for these also. If I go into the subsystem also, then this is perfect because this is Boolean value. But these are double. So we have to change the data type for these outputs now. So now I will explain how to convert any value to a fixed point. So suppose we have this value 0 here, and in the next example I have taken the value 3 here. So 0 and 3 both are unsigned numbers, so the second value, second bit here is 0 and the second value that you see here is 0. If these were signed numbers, then this value, this should be 1. Now 0 can be represented by just one by just one word length. For 3 we have to use 2 word length, that is 1 1 in binary. And this 0 means there are no floating point numbers. For 3 also, again 3 is not a floating point number, so this floating point length is 0. So in this example we have converted this 0 also to a fixed point and this 3 also to a fixed point. So here again all the variables that were present in our chart, we will convert them to a fixed point numbers. So now I went to the chart, and wherever there was 0, I declared it to be a variable as k0. And wherever there was 1, I declared it to be a variable as k1. So this became K1, K0, 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 K1. This become K0, K1, K0, 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 K1. And here also K1 and here also K0. So K0 and K1 are now the two variables. So if we run this, then here it is say that these K0 and K1 are unresolved symbols. So we will declare it to be a type of constant. So it told that these are unresolved symbols. These symbols were not defined. So we are defining these symbols as constant symbols. So click on OK. So now we will go into Model Explorer. So as you can see, these are A0, K0 and K1 are again of data type double. So we will declare them to be a data type Boolean. And its value is K0 value is logical 0. Click on apply. For K1 again it is a Boolean and its value is logical 1. Click on apply. So as you can see, now we have declared them as logical 0 and logical 1. So we will save it, Control S. We will save this. So as you can see now, and if we run this, then we should get this to be of Boolean type. So if we run, the type will change to Boolean now. So as you can see, it is Boolean has appeared here. So we have successfully changed the data type from double to Boolean. Also, now when we run check HDL, then you can see no messages, warnings or errors were found. So we have successfully made our state model to be compatible with hardware description language, that is VHDL or Verilog. Now we will go to apps and we will select the app as HDL coder. Go into settings. So I want to generate for Verilog. We can generate for VHDL Verilog or system Verilog. I want to generate for Verilog. Click on apply. Click on OK. Also, let me click on generate traceability report. Click on apply. Click on OK. Again, we will go to the MATLAB command window. And now, again, let us check for HDL. So it says no messages, warnings were found. Now we will write make HDL. So I am writing MAKE make HDL. So as you can see, it is working for making the HDL code for this. So these are the source files that are generated. So it has generated for our system or state flow diagram also, and Finally, for our traffic light controller subsystem also. So both the Verilog codes are generated. In this way, we can easily use the MATLAB and use the state flow diagram to generate the Verilog or VHDL code. Thank you. Please like and share the video and subscribe the channel.